2.3 is over inverse functions, another thing we've talked lots and lots about over the past few years. So we're just going to review some of the big ideas here. One, to be able to differentiate between the inverse of a function versus what it means to be an inverse function. And then we're going to use composition of functions to show f of x and g of x as inverse. And then show is one of those IB command terms. They actually want you to show it, to do it, pencil to paper, demonstrate through a series of steps. And then C, understand what it means to be one-to-one and how to use domain restrictions in creating inverse functions. So we might look at that one separately. Okay. So part A here, an inverse of a function versus an inverse function. So an inverse of a function is the relation formed when the domain and range of a function are interchanged. In other words, the x's become the y's and the y's become the x's. The inverse of a function may or may not be a function itself. That's important to remember. So for example, quadratic function, if I reflect it over the line y equals x, not a function, but that is the inverse of the function versus an inverse function. Okay. So the domain of a non-one-to-one function can be restricted to create an inverse function. Okay. We're going to briefly just review inverse functions. Remember, if we're going to actually calculate how to make an inverse function, you take the x and the y in the equation, you flip them, and then you solve for the new y. That would be the inverse of f of x. Okay. Here it's looked at in a graphic representation. This one right here represents this one right here. And if you'll notice, or try to remember, this is important, that if I'm looking at a function and its inverse, they'll always be reflected over the line y equals x. Okay. Here's a different one. This one is looking at quadratic. We reflect it. Remember, we're going to restrict the domain on this guy, so this one doesn't actually show. Right? We only look at the positive half here. Okay. And then here's a last one just to shore up some things that we may have forgotten about. If I have an exponential function and I switch the x and the y, I'm going to get a logarithmic function. So I have f of x equals 2 to the x. And the inverse of that, remember, is to take log base 2 of both sides. And you're going to get y equals log base 2 of x. That's this function inverse. And both reflected over the line y equals x. And this is just a little review here of logs. Right, remember 0, 2 to the 0 is 1, so log base 2 of 1 is 0. Just a little review. You can take some time to look through that if you'd like to. B, use composition of functions to show, that's a big word, show two functions are inverses. So we're going to use the definition here of a function inverse, which is that f of f inverse of x will always be x as well as the opposite composition. So this is with plugging in the inverse into the original function, and this is plugging in the function into the inverse. So when you look through the notes here, you can see they've got a problem worked out for you where they have an original f of x and they determine the inverse. And then they verify that y equals 4x minus 8 and y equals 1/4 x plus 2 are inverses by doing a composition of functions. Here they've plugged the inverse in as x, and then they distribute the 4 through, subtract the 8. Be careful with your parentheses where they actually go versus where they don't go. Simplify out, you get x. Cool, works. In this case, they're verifying by plugging in the original function. This is our original, and this is our inverse. Plugging our original in for x here, 1/4 of 4x minus 8, then plus 2. I promise that's an error that you guys tend to make. You don't forget that. So you would get 4x minus 2 plus 2. Oh, that's a 1x. It's 1/4 of 4 is 1. And then that gives us x also. So if you want to try this one by yourself without looking at it, you can, or you can just read through it, your choice.